Well, good morning, everyone, and welcome back to the 80s, and then welcome to today's webinar. The 1980s called, and they want their architectures back. My name is Don Pearson. I serve as Chief Strategy Officer with Inductive Automation. I'd like to welcome you today. Just one little housekeeping before we introduce the speakers today is you have questions, just use the chat off to the right. Put your questions in the chat box over to the right. And then we're going to basically get to as many questions at the end. We left pretty good time at the end for questions, so I think we should be able to get to all your questions at the close of today's presentations. Our speakers today are Todd Anslinger and Arlen Nipper. And Todd Anslinger is the IIoT Center of Excellence lead for Chevron. So first, I think I'll ask you, Todd, to do a little better introduction of yourself, and then I'll go to Arlen.
Okay, I'm Todd Anslinger, IoT Center of Excellence lead at Chevron, where I help the business units in the field, realize what the business value is of using the IoT network. But I've been working in the process control network since back in the days of pinch roll jeans and when untied high tops were totally rad. So now I'm looking to combine that PCN knowledge with IoT knowledge and shape how we modernize the PCN.
Thanks. Arlen?
Hello, Don. Thank you. My name is Arlen Nipper. I'm the president and CTO of Cirrus Link. I've been doing industrial communications for 42 years. So I'm happy to say that I was there in 1980. I was working for Coke Oil. Modbus had just come out. It came out in 1978. So I'm glad that the 1980s called and want their infrastructure back because, ironically, we're still building systems pretty much the way that we did in 1980.
Arlen, thanks. I think it might be true that a couple of things have changed as to our appearance if one looks to the 80s. There we go. So there was Arlen when he was back there in the 1980s. So I do want to comment, though, however, even though you look at us now, you might notice we're a little bit different. We don't dress the same. We don't look the same. It's ironic that we're still doing architectures the same. So here's your 80s architecture. I know you want it back, but the irony of it is we're still, as Arlen said, building architectures like we were back in the 80s. And I think that brings us to today's topic, looking at IIoT. I want to make a couple comments really to start off about this industry and where it sits right now. When you look at Industry 4.0, or you look at IIoT or digital transformation, whatever nomenclature you want to use, it really is the case that industry is going through a pretty big sea change right now. We really are in uncharted waters, and we've entered this new data-driven era, and companies are quite appropriately struggling to adapt to it. They're trying to make Industry 4.0 or IIoT real, and they're trying to make it work for them and make it work for them now. I think the thing I'd like to start with is that this sea change is pretty real, and it's causing a lot of pain points. A couple of years ago in one of our keynotes, I referenced a book I had read that was written by a guy named Eric Schaefer. He's a senior vice president with Accenture. And it's the Industry X.0, Realizing Digital Value in Industrial Sectors is the name of the book. And from that book, I just want to pull forward 3 items to set the stage, if you will, for the discussion today. First of those is a point he makes that the digital disruption and transformation of the industrial sphere is one of the world's current mega trends, affecting companies representing 2/3 of global GDP. So I think enough said on that one. It is a big deal. Second point is, he points out this really does mark the end of nearly 200 years of modern industrial production habits. The future is pretty much new to all of us with all of those big changes. And lastly, just digital connectivity really does change the game. The problem is that with the new game and new rules, there can be a lot more hype than actual substance. And I just want to point this out in terms of Gartner's hype cycle. something I'm sure many people are familiar with. But roughly this graph just shows on the hype cycle has a vertical axis that represents our expectations for a new technology. And the horizontal axis there is time. And you see these 5 different phases from technology trigger over to peak of inflated expectations, trough of disillusionment, and on to slope of enlightenment and the plateau of productivity. With regards to IIoT, the technology trigger has occurred and industry has passed through into this second phase here, the trough of disillusionment. We certainly have had high expectations of what would happen and how we could do it. Just get your data all up into the cloud and the world would be good, and you could do machine learning and you could advanced analytics and everything would be fine. And the interesting thing is, as you drop into the trough of disillusionment, change gets pretty tough. And really you end up with less than 5% adoption. And the industry overall is nowhere near getting off to that right side where you have the plateau of productivity. And that actually brings us to the topic of MQTT. And as Arlen mentioned, he is a co-inventor of MQTT. So I'll start with a quote from the co-inventor. MQTT and Sparkplug technology enables the opportunity for customers to modernize their existing OT infrastructures, resulting in not only superior OT solutions, but in an infrastructure that is ready to address digital transformation requirements, whatever they may be now or in the future. So MQTT being a topic here, let's just take a look at it in terms of messaging protocols. I mean, if you think about all of messaging standards that are being used for IoT solutions, MQTT is at the top there. And as you get down into those light red ones, they're just also RANs. There's nothing there that even vaguely competes. And ironically enough, when you think of the industrial sphere, you have to also realize that MQTT has huge penetration in the IT world already. And the trend is clear, as it shows in this next slide here. This is surveys done by Eclipse Foundation, and the results show over a 3-year period. On the far left bars, MQTT is growing at a strong rate. The next in line, HTTP, is moving down in terms of the utilization of these technologies, these standards, as they regard to IoT solutions. So as this next graph shows, it's pretty obvious. Not only is MQTT understood in the IT world, but it fits perfectly in terms of how people are actually using it now. And I think I'd like to make one point that really emphasizes where we're sitting right now, because I think the juncture that we're at right now allows us to really accelerate and get the exponential gains that can move us through that trough of disillusionment and over to plateaus of productivity. And you're going to hear from Todd and Arlen today some really strong specifics on that. But to set the table for that discussion, I just want to emphasize this point. Think of the Internet of People and how the Internet of People evolved. It actually evolved through 2 important open technologies, HTTP as the message transport, and HTML as the definition of what is transported. So you had Hypertext Transfer Protocol. It's an open protocol and defines how data ends up being transferred over the internet. And HTML was, of course, the hypertext markup language. Now, if you cross over by comparison, IIoT to truly take off and get out of that Gartner hype cycle has to also have 2 technologies that work. Think about it. To scale to its full potential, the same type of open and simple technologies are needed. MQTT, it's become the dominant IoT messaging transport. It's open and it's simple. And Sparkplug, it's an open specification, defines the structure and state of the data within MQTT messages. So if you think about that on the next slide, really, we're talking about the industrial Internet of Things and open technologies that can empower innovation. Really, in simple terms, MQTT is the message transport, and Sparkplug is the definition of what is transported. So the parallels, I think the parallels are pretty obvious. For the Internet of People, it's HTTP and HTML. For the Internet of Things, it's MQTT and Sparkplug. Sparkplug. When you think about it, really what we're talking about here is a specification that is completely independent, open standard that defines how to use MQTT in your mission critical real-time environments. Sparkplug, it's a pretty great example of how collaboration can lead to open solutions. And frankly, the Eclipse Foundation is a perfect place for its home because it provides a mature, scalable, commercially focused environment for collaboration and for innovation. So with that as sort of setting the table for the discussion, I think what I'd like to do now is we need industrial organizations to use, to adopt, to improve, to find value in. So I'm going to turn it over to you, Todd, and let you take it away from here.
All right, thank you. I'm going to talk about how we do things now in the PCN and the business problems we're trying to solve. Before I do that, though, if you came in late and you have a question, just type it over there on the right side in the chat, and we'll get to them at the end. So, like with any new technology, we don't want to apply a technology just for technology's sake. We need to have a business problem we're trying to solve to bring that value to the organization. So from a Chevron standpoint, this is what we're trying to solve. We have business units that are commissioning facilities every week of the year. Okay, so the things that figure into that are the integration time in the PCN, the integration time into the business systems, which engineering may not always consider, but that's a significant chunk of time too as well. And then, integrating in the property swaps you may have, we're buying and selling different properties, and then just the day-to-day changes you may have on existing facilities. So these are all things that are wrapped around changing our workflows. So if we go to the next one here, what are the challenges in that? Okay, so from a manpower standpoint, in years past, they've said, okay, we're going to double the number of our facilities, but we're only going to add 30% more people. Okay, so that means we've got to be more efficient with how we do our work. Okay, and then from a numbers of devices we need to integrate, if you think about it, what's needed to be updated per facility is, there's going to be a PLC, you're going to have a local touchscreen interface right there at the facility, you have control room graphics back at the office, you've got your historian, and then your decision and support center that sits over multiple control rooms to kind of help them do more of the weeks to months type of thing. And then, of course, when we're doing these things, how we've been doing it for the last several years, 40 years, we have to integrate these things in series. It's got to be done point by point to check out each of those one-to-one correlations. So that gets us over to the next one where we look at what are we talking about the process now being. Okay, so if you just look at the boxes as separate integration points, you have, 9 integration points to get the data to where you want it to be to take advantage of the business value of that data. All right. And then you've got each arrow indicates a one-to-one pull response verification point that you need to verify. And that has to be done in series. So looking at this here, okay, we're doing pull response. And if we say, okay, how does that compare to publisher subscriber? Well, the wired sensor running conduit pulling wire, that's not going to change. So, but you have your PLC integrator, which is probably going to be the same as your local touchscreen integrator that has to make changes at the facility. Then you've got your development team back at the office doing control room HMI changes, and then from a Chevron standpoint, we dump out flat files from our HMI through a firewall, put them into the DMZ, and then the production database reaches through the firewall from the business side to pull that up there. Okay, so we have to complete that transfer. And then within level 3, we kick over the stuff from the HMI into our process historian, move it to a PI aggregator in the DMZ through a firewall, and push it to a PI to PI transfer to level 4. So you can see those all have to be done. That has to be in the PLC first, and we propagate that up in series to make all that happen. So from a full end-to-end standpoint, when we add a facility to our network, it takes 6 weeks. That includes, engineering drawings, all the work that's got to be done in integration, and then testing the I/O. So if you go back to my thinking about my first one, I said we're doing one every week, but it takes 6 weeks to finish the process. We have to have 6 times the number of people to do that. So that's an issue. So where are we going with this on the next slide here? We're looking at what does it look like now? Okay, so this is what it looks like. You've got your SCADA host that's pulling all your different PLCs, DCSs in the field, and it's feeding data up to our business systems that's over on the enterprise IT side. Okay, and that doesn't look too bad for one plant, but what does it mean for the enterprise? So if we go to the next one, we look at the enterprise, you may have multiple SCADA hosts, you see there on the right side, that you have that's feeding information to your singular enterprise business systems. Okay, so if you have to make a one-to-one connection to make the relationship happen for all of these to get to your business system, that starts looking like a bowl of spaghetti. All right, and that's just for 6 SCADA hosts over there. So, that makes 36 different connections. Okay, you still might think, okay, that's not too bad. But if we look at like the Chevron enterprise, this being one business unit, our business units have on average 60 SCADA hosts per business unit that feed into their business systems. So you're talking 360 connections to be built, maintained, and managed per business unit. And then how many business units does Chevron have is your next question. Well, we have 43. So I'll spare you the math, but that's 15,000 one-to-one connection relationships that have to be built, maintained, managed, troubleshot. And that is quite, for a large team, that's quite unmanageable. So the next one, how can we change what we're doing here? So we can keep how our system looks now with the SCADA host being the message-oriented middleware, and we can just re-architect it just a little bit, which Arlen is going to talk about here after the next couple slides. So as kind of a precursor to Arlen, I want to get your mind thinking about how publisher subscriber can help large enterprises with how they're doing their integration and their data management. Okay, so the first one is just the nature of publisher subscriber. It only sends values when the values change. So if you think about when you're polling your PLC, what values are changing? That's mainly your process variables, your pressures, your temperatures, your levels, those type of things. But when you poll that PLC information, you're also polling alarm set points, alarm discretes, P&ID loop tuning parameters, process set points. You're pulling all of these things, which are, about 10 to 15% is actual values that are changing. So you're wasting a lot of time and energy pulling those things that don't change. The other thing is store and forward is built into the software. We could buy, being that oil and gas, we have these old Ethernet radio systems that are polling things. Well, sometimes we're operating close to the noise floor and we get dropped out. So that leaves a hole. If you go in to trend that in our historian, that leaves zeros in your data that you're trying to trend, and that upsets facilities and process engineers and all types of those things. So to mitigate that, we could put a $10,000 card in every PLC to handle that store and forward, but with a number of PLCs that Chevron had, that we just cannot do that. That's too expensive to do that. Publisher subscriber, also, we're going to show you how it reduces the integration time for standard facilities. I'll show you that later after Arlen. And then if we had a standard that all the operators used publisher subscriber, when we do these property swaps, which happens more often than you really think or know, we could point that edge device to a new broker that we spin up, and we could have all those tags in a matter of seconds or minutes versus poll response. Because you might say, oh, well, we already have a standard Modbus RTU, and that could be the standard. Well, yes, but you would have to set up all those polls and polls to pull that data up to a new data server, and that would take you weeks to months to happen. So we're talking about changing workflows. It could happen in a matter of seconds. So that gets us to the next one, to Arlen here. Now, everyone that has been doing SCADA for 5 to 40 years, I need you to look right here. All right, because I want you to forget what you know about SCADA, and I want you to think about how you would want it to work.
Thanks, Todd. That was great. So this is all about, what we're talking about here is aligning OT and IT. And again, if to your point, Todd, if you just go out there right now and look, and the proposition that we're all seeing with the advent of all the cloud service providers and all of the IT technology that we have, it looks pretty simple, right? We got all these great tools, we've got these services, we've got new software and platforms, and all we have to do is plug in the OT data. Looks simple. But we know that the reality is it's difficult. It's very difficult to get an architecture at the OT level that's ready to plug into our IT systems, whether they're cloud, whether they're business back-end systems. So what we have to look at is how can we provide technology at the OT level? So let's, instead of looking at this from IT down to OT, let's enable technology at the OT level so that when an OT system is implemented, it's IT ready, first and foremost. So we do have OT versus IT, and this isn't a confrontational. It is the reality of, you know, the experience and the tribal knowledge that we've got on the OT side with all the proprietary poll response protocols, with all of the different networks we've got, with the different data formats, the fact that the data that we get from our PLCs, whether they're on the factory floor or our flow computers or our solar monitoring systems, are all very specific to those markets. But then we go over to the IT side and we want to reuse tools. We want to make everything standard. We want to try to make that transition as easy as possible. Our job is to take that OT data to where it's easily understood by another regular human being in the world. We don't need a flow computer expert or a factory manufacturing expert to try to figure out all of this information. So, and one of the other things that I realize now is that we now have kind of a common denominator in that the understanding and the realization of MQTT is distributed very wide. So I don't have to go to a particular expert that understands a particular protocol like Modbus RTU or Allen Bradley or HART, but I can expose that as data objects. So the challenge is providing OT with tools and technologies to implement a superior OT solution first, but the result is an infrastructure design that's IT ready. So to start with, MQTT. I will, like Don said, I am the co-inventor of MQTT, and it was actually invented on a project for Phillips 66 pipeline out of Bartlesville, Oklahoma. They had just gotten their brand new TCP/IP based VSAT system, and they wanted to use it more efficiently. As people on this call may know, polling over a VSAT system is very slow. And at the time, it was very expensive. So how could we get information from the PLCs, the flow computers, the gas chromatographs, the smart sensors at a booster station or at a pump station or any remote location? How could we get that information in more reliably and more securely? So the original design goals of MQTT was, number one, it had to be simple. At the time, we were relegated to 8-bit microprocessors with maybe 64K of memory. So by its very nature, it had to be simple. Number two, it had to be efficient. We were paying for bandwidth by the byte. I mean, when Andy and I were working on MQTT, we had this notion that every byte that we could save was $1 million over the course of a year. So, you know, Andy would come in and say, oh man, I just figured out a way to save another $100,000. So again, efficiency is still today. We've somewhat forgotten that we still have to be efficient. And then the third thing was state. We had to have a method to have stateful awareness, because I can't do report by exception if I don't have state, and I surely can't do command and control if I don't know the state of the devices that are in my MQTT infrastructure. Now, the fourth point here is we have to include that, is it has to be secure. Now, in 1999, 2000, Andy and I really weren't worried about that. You know, there was no real notion of that. But the advantage is that we designed MQTT to set squarely on top of TCP/IP. And the advantage here in 2020 is that lets us take advantage of the latest TCP/IP security technology, whatever that is today, and more importantly, what is that going to be tomorrow? And then lastly, as you can imagine, in 1999 with IBM, took us longer to convince IBM that this had to be open. In other words, it had to be an open specification so that everybody could participate. I had just come from 25 years of all of the protocols that were proprietary that you couldn't get information on, and we had to break that vicious cycle. So to Todd's point, in the early 2000s, we literally took systems that looked like this, and by using appropriate edge of network technology and working with vendors on SCADA host systems and things like that, we were able to transition from this model to this model. So we literally, as we did this, and we worked with IBM again for probably the first decade in putting these systems together, it was all very nice because we had a single vendor, we had a single edge of network device. But now, as we're over the last 5-6 years, we're seeing issues start to emerge. Each OEM device has a different topic and payload. So as I was looking at the market here 4 or 5 years ago, we had a lot of people adopting MQTT. But to Todd's point, everybody was adopting it differently. So we didn't have any plug and play capabilities. Early applications in the cloud especially were assuming JSON. Now there's nothing wrong with JSON, but to Todd's point, bandwidth is neither free nor unlimited in many of the applications that we go into. So we've got to keep that notion of keeping MQTT lean and mean on the wire. The third thing was applications. It's funny, people read the MQTT spec and they go, pub sub, this is great. I can publish anything. I can subscribe to anything. And then they kind of stop reading the spec and really didn't understand why Andy and I designed the last will and testament into an MQTT session so that can maintain the state. And even today, we're still seeing a lot of implementations where process variables are still seen as key value pairs, and that's not going to scale. Into my next point, when we started doing this, AWS, Microsoft Azure, IBM Watson, Google Cloud Platform, they didn't even exist. And the emergence of cloud computing and those services has really changed our mindset now in 2020 of how we want to go design these infrastructures to be not only OT compliant, but be able to plug in the cloud architectures. So about 4 years ago, we started looking at all of the work that Cirrus had done in implementing MQTT OT systems. And it's like, well, let's sit down and let's take best practices, lessons learned over that 20-year period, and let's write a specification that defines best practices that we've seen for MQTT and OT solutions. So the first point here is that Sparkplug does not change the MQTT standard in any way, but it defines best practices on how to use MQTT in our IIoT or OT infrastructures. So if we look here, Sparkplug B, the first thing that it does, it defines an OT-centric topic namespace. Now, what does that give us? That gives us the ability for plug-and-play auto-discovery. If I have a well-known topic namespace, that means that any MQTT client can come into an MQTT infrastructure with proper security and proper permissions and do a wildcard subscription. And then with that and a known topic namespace, it can auto-discover. So at the top level, Sparkplug defines a group, a node, and a device. So when I see that message come across, I look at the topic and I go, oh, I know where this message came from. The next thing is that it defines this notion of a birth. And a birth of either a node or a device tells my client that, oh, I've got a new device out there in the field that I can discover and figure out what it is and what it wants to do. Now, once I've done my birth, now I've got the ability to publish data, either in data or D data. And that's the report by exception capability that we can build in using Sparkplug, so that on a birth, we publish all of our process variables. So now we know the state of everything. But as long as that MQTT session is up, all we need to do is publish any process variable that changed. And of course, this is command and control. So Sparkplug defines the notion of a command so that I can have node device level commands for bidirectional command and control. And then lastly, kind of the bookend of I've got a birth, I'm online, I'm publishing data, I've got D data, in data coming across, I can publish commands. But if I fall off and if I get that death certificate that MQTT provides us, now we can get a notification of a death of a device or a node. So that if I'm in a control system, now I know that node is no longer online. I've had rain fade at the facility. In the factory, I've had a network go down. So that death message is going to tell my control system that for those devices, I should set all the tags stale. Now, the next thing that Sparkplug does is that it defines the ability. So Sparkplug template definition allows a birth message to define data models. Now, we built this in originally 4 years ago in the first iteration of Sparkplug, but it was a very good idea, but we didn't really know where we were going to leverage that. But let's fast forward to 2020 in the fact that now we have services that basically depend on the fact that we have a data model. And once we have a model, we instantiate that to create an asset. And those assets contain our measurements, our process variables, our tags, whatever you want to call those pressures and temperatures and flow rates and production counts and things like that. So it's very important moving forward in modern infrastructure that we've got the ability to build a model, an asset, and populate that with measurements. Now, the third thing is that we needed to have an efficient binary encoding of a process variable object. Remember what I told you is that for the last, since 1980, probably before then, our whole notion for the last 40 years is a tag, a key value pair. We have a Modbus register 40,001, and the value is 12. 12 what? So what do? Humans double click on that Modbus register, and they give it metadata. They give it a name, they give it engineering units, they say, oh, we need to scale this, here's the engineering ranges, here's some custom properties that we need to add to this process variable. Well, Sparkplug now gives us the ability to basically create a process variable or a measurement object. And that object lives in the fact that it has all the information I need for that process variable, whether that came in just now or whether that came in 2 years ago. I've got a name, I've got a value, timestamp, I've got the data type, and it establishes kind of that single source of truth for my measurements out in the field. And then the fourth thing Sparkplug does is it defines MQTT state management. And with state management now, I can do report by exception. I can do bidirectional command and control. And to Todd's point, if I know the state and my client at the edge knows that it's gone offline and I've got process variable objects, that means that those can go into a queue. And when my MQTT connection is restored, now I can do report all the store and forward because I've got the timestamps of when those values were measured. So the really important thing here going forward is that Sparkplug establishes a single source of truth for models, assets, and tags at the origin of as far out in our OT infrastructure as we can. So with that, I'm going to turn it back over to Todd to talk about how he sees the advantages of Sparkplug and MQTT.
Thanks, Arlen. Over to you, Todd.
Okay, so I alluded to being more efficient with the integration in your PCN. So I'm just going to share some research that we did in Chevron a couple years ago. We just took simple Lean Sigma time measurements on how long it takes to propagate a standard object through the PCN. Okay, so there was 3 different systems we used. One was a single vendor with the same vendor touchscreen, a different vendor's HMI going to our standard historian. That was one system. The second system was a single vendor all the way from the PLC to the historian, so you could take advantage of some, common tag name databases. And then the third one was a publisher subscriber solution. So we'll look at the architects or the diagrams, kind of so you can get an idea of what we're talking about here. Nothing fancy. It's stuff that you're used to seeing. It's just, in the one we had 2 different vendors. In the middle one, we've got a single vendor. And on the third one, we're adding in the publisher subscriber, the brokers at level 3 and in the cloud. Okay, so that gets us to, I'm not going to do any, suspense, and I'm going to give you the details right away. All right, so when we did this, the system that we have in some of our Chevron standard locations took 22 minutes to add the tank object, link it up to the 4 to 20 for the the level coming in, downloading it, configuring the touchscreen, configuring the control room HMI, and then dumping that out into our historian. So 22 minutes to do that. Okay, now if you take a single vertical vendor, that reduced it to, about 50% of the time, which you would think you'd take advantage of some advantages by having a single tag name database. But in the publisher subscriber system, you're down to 20% of what it takes to do the way we used to do it. Okay, so and basically that's adding the object, linking up the 4 to 20 milliamp, setting the set points, downloading it, you're done. All right, because at that point, that since the PLC was the publisher, it published it out to everything, and all the dashboards, all the HMI graphics, all the historians, it just showed up. All right. And really, this is not an apples to apples comparison, because that 4.5 minutes, that included the mobility piece, so it shows up on your cell phone, which the first 2 does not have. So you could even say it was even less than that, because you get more benefits. So going on to the next one here. So what are the different variations of MQTT? I know you've heard that a lot. And Arlen's mentioned that MQTT is an open protocol, which is great. That's great. It's open protocol. But the bad side is MQTT is an open protocol. All right. So there's no standard out there. Everyone can create their own. All right. Now that's why we're focusing on Sparkplug here. And I want to give you the business benefits of these different bullet points that Sparkplug gives us. Okay, so the first one was with the birth certificate and the death certificate. That gives me 3 distinct things actually that I want to talk about. One is the session awareness. That is very important, and I'll give you a story why. More than 15 years ago, I was part of a project where we were polling a saltwater disposal. Okay, and they were just changing their operations to be, okay, let's look at it in the control room before we send someone out, type of thing. Well, so the operator looks at the tank levels and says, oh, there's 10 feet of water in this 25-foot tank. No problem. Well, a day and a half goes by and he receives a phone call and says, hey, yeah, there's a sign here that says, call this number if there's a problem, if you see an issue, and there's water running down on the road here, so I thought I'd let you know. Well, what happened is there was a lightning strike, knocked out the power, the valve didn't close, so the water kept coming in and we had a spill, right? That's bad news. That's environmental release. That's bad news. But it's because we didn't have that session awareness indicated, so we didn't know that we weren't talking to that facility. The operator just clicked through the screen, said, oh, 10 feet, we're good, goes to the next screen, okay? That's the reason why we have to have this session awareness. It's very important. Now, the second part of that birth certificate is, what could this mean to our business systems? Like, let's say your maintenance system. When you add a pump in the field, you have to tell the maintenance planner, and he adds it into, your CMMS, and so he can set up all of your PM stuff, your 90-day PMs, all the stuff that happens with that. Well, if your CMMS could recognize a birth certificate in the broker, and it says, oh, this is one of my standard pumps, pull it in, and it automatically creates your maintenance system stuff for you, that's a workflow improvement, right? So that's the second thing. The third thing with that birth certificate, and we've alluded to this too, is, with data being king now, if your analytics if your machine learning system, if it could recognize that birth certificate and say, oh, I see this is a standard pump, I'm going to apply on top of this pump the analytics to go with it with this pump. And I'm not talking about just a pump. I'm talking about, if you look at your P&ID, you draw a circle around there, having your suction pressure, your discharge pressure, your flow rate, your pump speed, your vibration. You can have analytics all wrapped around those things, and you just apply it to it, rather than having to do a one-to-one link. Okay, I've got to link the discharge pressure to here, the suction pressure to here. It could just happen. All right, and that's what we're talking about, is the workflow changes. So that's the big thing about the birth and death certificate that I'm excited about. The next one, and Arlen said this, is it puts in the topic namespace into the tag name. All right, so basically you can look at that, you can know exactly where that is. And that's important, because if you didn't have that, you would have to have a JSON coder go into the message where the JSON scripting is and add in your hierarchy in the JSON scripting. So we don't need that JSON coder. All right, now, and then the third one is, this is managed, Sparkplug is managed by the Eclipse Foundation. So it's an open standard. And the reason why that's important is that if you go to your vendors and say, hey, I want you to implement Chevron's flavor of MQTT in your EFMs or your PLCs or your edge devices, what's their value to do, or what's their push to do that? All right, because it's only going to increase sales to Chevron. If they have an open standard they can take, now they see, and people are using it, they can see, oh, yeah, I'm going to bake this in because I'm going to get more money because I'm going to sell more devices. All right, which leads to the last one, is vendors have Sparkplug compliant PLCs, communications cards, edge devices right now that you can use in your system. Okay, so that gets us to the summary of the business, kind of the business value of why it's important for large enterprises to have a standard and to use Sparkplug specifically. And one is, publisher subscriber, just by its nature, cuts integration time significantly. All right, then the next one is additions and changes just automatically show up through the levels and even the business systems with the proper context. I should have bolded that, with the proper context, because like Arlen mentioned, if we send a Modbus 42 up to the HMI or the historian, that could be 42 inches, 42 feet. That could be 4.2 feet, because you automatically assume a decimal point change, which is another thing that's very important, because I've been part of projects where I was sending 40 and the guy thought I meant 4.0, but it was actually 40 feet, another spill. So there's all kinds of lessons learned in here that increases, the need for something like this. All right, and then the third one, PubSub pushes updates to the broker only when the value changes. So therefore, we only use about a 15% of our bandwidth that we were using, which is important. Like Arlen mentioned, when you're having, metered backhaul, being a satellite, being cellular type of thing. And also if it's inside your SCADA system, then that opens up to new technology you can use for cameras or what have you. Okay, and then the big thing, make sure you have to have session awareness. If you're going to do command and control, like Arlen said, you have to have session awareness so you know that you're connected to there to avoid running blind. Okay, so, and then the last one, which with regards to Eclipse Foundation housing this Sparkplug specification, if you're a part of it, you can influence that open standard rather than making your own. Because to be quite honest, if you can influence, if that's open standard and it's baked into devices, you can grab off the shelf things to fit, what's broken in your system. You can take it off the shelf, you can put it in there. You don't have to add your own proprietary containers, things, and customizing it, because we want to avoid customization at all point, risk. And then, of course, for the cost of joining the Sparkplug working group, Chevron would pay that same amount just to onboard a resource to manage the Chevron specific protocol. So there's many things that you can take advantage of by being influencing this protocol.
Thank you so much. I think you made it pretty darn real, Todd. I totally appreciate you going into all that detail. And also the value. I know we've been involved in the working group ourselves for a long time. We're very much in favor of why it's so important. And I think you nailed it. How are you going to, as a company, be able to influence an open standard? Well, it's pretty simple. Join MQTT Sparkplug Working Group with the Eclipse Foundation and participate. Because if you do that, just to punctuate what Todd's saying, it ensures that you, your company, your industry, you have a voice in how the specification is maintained and how it's evolved, assist with certification guidelines. So when you see, hardware and software products that are MQTT Sparkplug enabled, they meet all the standards, and you can assist also with educating the community about the benefits of MQTT and Sparkplug, like this particular webinar. I mean, you get involved in the group, and that's a way you can contribute to that evolution. As a participant in this webinar, just so you know, those who are on the webinar and maybe first introduction to this, we're going to send you a thank you email that includes the above link to the MQTT Sparkplug Working Group, as well as membership prospectus and a link to join the communication channel via Slack or email updates. And I already saw on the channel over here that Larry's put up some links. The Eclipse Foundation has put links there, so you'll have those there in that channel. Now, that actually finishes our presentation portion, but we also want to make sure, I mentioned it, Todd mentioned it, that we get a chance to answer your questions now. We have a little bit of time left in the Q&A portion of this. So use the chat to put questions in, and we will answer them and take care of it. It says, so I'm looking at the chat thing, and I will read any questions that come. It looks like they've been being answered also as we've gone along. Here's a question: is there any easy way to find devices and software that are compatible with Sparkplug now? So I'm going to turn that over to you, Arlen, if you want to comment on that.
Well, we try on the Cirrus Link website. We try to list as many devices that we know about that are natively Sparkplug enabled. Just off the top of my head, their Signal Fire has a sensor that is native Sparkplug. You've got Wago PLCs that have it built in. We have more and more Opto22. Then you've got companies like Moxa and Advantech and OnLogic and companies that are in the Inductive Automation's onboard program, where those devices have the ability to do Sparkplug natively as well. And on the Slack channel, you can ask people. There's more and more. I'm always amazed by devices that are just showing up that are Sparkplug enabled natively.
Thanks, Arlen. And yeah, clearly at Inductive Automation, we're going to continue to push our Ignition onboard program, and that is those devices and some of the companies you mentioned are all part of the onboard program, so that the Sparkplug compliance is being pushed. Another question here. I just wonder how industrial plants approach to recent developments of industrial communication, ? Cheers. So I'll read that again. It's kind of a statement question. I just wonder how industrial plants approach to recent developments of industrial communications. I think, how is it going? What's happening in that area, I think, is the question. Todd, any thoughts on that? And then Arlen, either one of you or both?
I think it's probably going to matter how many different, kind of like I alluded to, how many different SCADA hosts are you connecting to business systems? In upstream world, this is, we have to have this type of thing. Downstream, if you're making a lot of changes, I also see advantages to using Sparkplug and to using publisher subscriber, just because of the sheer number of changes that happen in the system. There's large support groups that handle a lot of these things, and this would just make their life easier. They can focus on not checking point-to-point stuff and focus on getting value out of the data.
Yeah, I agree, Todd, in that, we look out there, there's not a lot of, and, anybody on this webinar can correct me if I'm wrong. There's OPCUA, and they've got a pub sub spec, and there's Sparkplug. And I don't want to, we use OPCUA to connect into devices that's integrated in, and then Sparkplug can be used to take those process variables and those models and publish them up. So I think we're seeing adoption, as Cirrus Link, we're seeing adoption across all the markets horizontally. I mean, whether it's food and beverage, manufacturing, solar, water, wastewater, oil and gas, we're seeing the same issues that Todd brought up specific to oil and gas actually go across all other industries as well. So even in plant where, they've got brownfield equipment that needs to be integrated in, it needs to build a model. We have a lot of customers that are taking an operation on a factory floor. Let's say a stamping operation for an auto parts manufacturer. And they've got one brand of 20-year-old PLC that's looking at the conveyor, and then a different model of PLC looking at the pneumatic tube, and another PLC, a different model looking at the crowding station. And what they're able to do with Sparkplug was take all those different PLCs with all of those really cryptic process variables, build a model, give that process, that stamping process, give it context so that by the time it gets up into their back-end systems, they don't need to know, oh gosh, this was Modbus and this was an Omron PLC and this was an Allen Bradley and this was a discrete. All they see is a model that's a stamping machine, the instantiation of that as an asset, and that asset has all of the process variables already in engineering units, already with definitions around that. So I see it being adopted across all industry sectors.
Yeah, and I want to add back on to what Arlen said, because even in a plant, if you think about where is it that you get the value out of the data, it's when you combine it into your object. So that could be in your HMI, that could be in your historian, and then anything downstream of that, or up in levels, can take advantage of that object. Well, what we're talking about here is it wraps it into the data protocol, to the transport. So you're wrapping in that object at the lowest level. So that creates advantages, from that lowest level on. You could take advantage of that even at your local touchscreen, as well as it propagates up through your system. So again, it saves you time, and you're transporting the object in the transport layer, not in the database layer. So huge value in that.
Thanks, Todd and Arlen, both. Oh, I got a couple more questions here. I'll ask this one to both, maybe. I understand the what and the why. Still wondering about the how. How can I set up an easily understandable and affordable proof of concept? Arlen, you want to take a shot at that?
Well, one of the things I mentioned before, I do a lot of talks, go out, and, if I was at a university and I've got, the 2020 graduating class of electrical engineers and data scientists, and, I'm doing a presentation. And if I ask that audience, how many of you students that want to go into automation have ever heard of OPCUA? Raise your hands. Nothing. What about Modbus RTU? Allen Bradley DF1, HART protocol, Emerson Rock protocol? Nothing. But if I ask that same audience, how many of you have a Raspberry Pi in your dorm room? You probably are running Node-RED. You've probably downloaded the Alexa app from Amazon. You're talking to Alexa, sending MQTT commands to turn the LED on your Raspberry Pi, and hands go up like crazy. So my point is that Raspberry Pi comes with Node-RED. Node-RED has an MQTT Sparkplug module that can be loaded in, and that would be a very quick and easy way to get started. There are also a lot of other options out there. There's Ignition Maker Edition, which is a free version of a SCADA host system that would let you set up infrastructure and set up a Sparkplug infrastructure, and literally for zero cost, or maybe the cost of a Raspberry Pi, get started and see how it works.
Thanks, Arlen. We got a couple more questions here. Is there a standard way to encode the onboard GNSS's LAT/LON current, let me see, I just moved, current location of the sensors or gateway, in case the gateway or sensor is a mobile platform?
Oh, absolutely. We have people that are tacking on. So when a device does a debirth or an in-birth, the node itself, part of that birth certificate includes a an object, a model, if you will, of geolocation, and within that we've got lat long. We can do GPS timestamping. All of that is already being done from a mobile platform standpoint.
That's great. We've got a lot of action here. So here's another question. Can Sparkplug be used to develop a node set meta model for your published topics types and message types?
Whoa. Well, I think the answer to that is yes, in that, again, Sparkplug defines a standard topic namespace. We don't want to break that, at least not now. And again, one of the things that we built in, and the reason we call it Sparkplug B, is that now we have the ability to go to Sparkplug C and Sparkplug D, because that's the first part of the topic. It tells me what version of Sparkplug I'm using. So I literally know that as we progress, we will have systems consuming Sparkplug B messages and Sparkplug C and Sparkplug D. So we've got that already baked into the roadmap, if you will, of the Sparkplug specification. And that's the very reason we're having this webinar, is we're asking people that have ideas, that want to see something. Well, the way to do that is join the Sparkplug working group, bring your ideas, and help us bring all this to fruition.
Thanks, Arlen. I'm not sure if I asked this one already, because I got lost in the chat screens here, but can you talk about any large-scale deployments using Sparkplug that you are aware of? Did I ask you that question? And if not, I'm asking it now.
Yes, there are very large-scale deployments. Unfortunately, I think, as everybody knows on this call, the larger the customer, the larger the NDA on not being able to talk about that. But
that's true. That's true. That sort of puts a little quash on that.
Yes. I can tell you there are some, one place to look for some very large deployments that are public are on Ignition. Inductive Automation have a gallery of all the systems that have been put together, and you'll see that many of those solar monitoring, pipeline upstream and midstream, factories. We have a lot of very large scale deployments, and I can't say who it is, but some of the largest companies in the world are definitely taking advantage of Sparkplug technology, and Chevron on here as well.
Yeah, I would certainly say that if we do not have an NDA stopping us, we do a pretty good job of the Discover Gallery at the Inductive Automation site, and we just published some more with our conference this last week. So please, if we can talk about it and the customer's willing, we do have the option to do that, and we take advantage of that wherever possible. Listen, we're coming towards the end of our time here. I actually want to go to each of our speakers and give you a chance to give any final statements you want before we end off. I think I'll start with you, Todd, and then let you finish us off and bring it home with a conclusion, Arlen.
Okay, yeah, I just want to say, if you have a standard that you want to, instead of you doing it yourself, be a part of this group and help drive it. If you want to build your certain things into it, that's why you have relationships with the big PLCs, DCSs, so they build stuff in for you. This is the same thing you can do from a protocol standpoint that allows much more open standard.
Thank you.
Yeah, I agree. And to me, it's been me personally watching MQTT over the last 22 years. Andy and I had no idea that it would scale to this level. I think it was really the fact of keep it simple, stupid. It was very straightforward. And now the leverage that we're getting and the interest that we're getting in Sparkplug and how people can actually start applying this. And again, I would say get involved. We need help in the designing the TCKs in the Tahoe project. Yep. So, again, take a look at the prospectus that we're going to email out to you, and let's get involved.
Todd, Arlen, thanks to both of you. Hopefully this was useful information. It looks like it was from the chat. You have follow-up opportunities with what we're sending out to you and what was also put in links in the chat. So with that, we're at a conclusion point. Thank you very much for attending. Have a great day.
Thanks.